Hi, I'm Hyan Lee. I will present our paper, Lightweight Neural Architecture Search with Parameter Remapping and Knowledge Distillation. NAS is spun out to build a better model with stronger performance and higher efficiency for a given task. However, existing NAS frameworks suffer from being actively used for a real-world task. For example, one of popular NAS, one-shot NAS method require a large computational cost and time for each dataset to build a supernet. And another popular NAS, zero-cost NAS method are fast enough. However, they show low performance. Also, they usually simply use random initialized parameter to estimate architecture performance, so most of them cannot capture the distributional distinctiveness of the various datasets. So we propose a new NAS method that works with a lightweight search cost and high search performance for real-world scenarios. For this, we propose a proxy to estimate the accuracy performance of architecture candidates by distilling knowledge from the reference network. However, distilling knowledge on many student architecture candidates is too slow. This is because it requires a lot of knowledge distillation steps to build a reliable performance estimation. Thus, we update the proxy to shorten distillation step by remapping parameter before distilling knowledge from the reference network. Specifically, we first train the reference network on a target dataset. In this work, we regard the largest network we can get from the search space as the reference network. Then we map the trained parameter of the reference block to the candidate blocks. And if the size of candidate block is smaller than the reference block, then we remap parameter, corresponding parameter layer-wisely and channel-wisely. Then we conduct a distillation of block-wise feature map by minimizing the mean square error loss between the reference block and the parameter remap student blocks. Finally, we can assemble any candidate model by taking the block corresponding to a configuration of the model from the block view. Then we use an average accuracy of a given model as the proxy for the final accuracy. For the experiment, we consider MobileNet version 3 search space. And to validate our model's performance, we compute Spearman's length correlation coefficients between estimated and actual accuracy on CIFAR-10. And as shown in this table, our model outperformed other baselines such as flow-based proxy or zero-cost NAS-based proxy. Also, we analyzed the effect of fine-tuning the pre-trained model with the proposed method. Initializing with parameter remapping or parameter remapping with distillation also show better performance compared to Scratch, that means randomly initialized parameter, and show comparable performance to distillation-only model. Also, we observed that using both parameter remapping and knowledge distillation largely outperform the others that consider only a single component. For example, if we consider parameter remapper only, then the linking correlation performance is poor. And if we consider distillation only, then we require a large number of training steps to get a reliable linking correlation. In this result, we can observe that parameter remapping largely help our proxy to predict the performance more accurately, even in the early batch by utilizing the trained parameters. This is conclusion. We propose a simple yet effective proxy that combines block-wise parameter remapping and knowledge distillation. Parameter remapping significantly reduced the number of training steps as just a few steps during distillation. The model also can be used as the pre-trained weight that makes model to obtain higher performance at the end.